Hi, you're welcome to Explore Insight. In this video, I want to talk about second complement subtraction. But before I proceed, I would like to mention that I have treated the first complement subtraction, which has to consider case 1 and case 2. Case 1, which is about the subtraction of large number from small number, and case 2, which has to do with subtraction of small number from large number. So if you have not watched that, please go to my previous videos and look at those tricks I've used in solving the question there. So without any further ado, please let's get started on 2's complement subtraction. Now I'm going to treat on first case and second case in my next video. So for the case 1, it will be a subtraction of large numbers from small numbers. And take note, I represented the small number as x, whereas the large number as L. Now the small number is the minor end, while the large number is the superhand. So we'll go through this calculation with just 4 steps. The first one is to take the second complement of superhand. Now whatever value we have, we're going to add it to the minor end, which is the second step. And then we move further to consider if carry is generated, then the result is said to be negative and is in its second complement form. And lastly, which is the step 4, we'll take the second complement again to get the actual result. Now, for you to better understand this, let me treat an example. So stay tuned. Now we are asked to subtract 72 from 54. So basically, that's to say 54 minus 72. Now 54 is said to be the minor end and 72 is the superhand. The next thing to consider is we have to convert this to binary form. How do we do that? I have a trick to that, which is fast and easy to understand and to apply during your exam. Now I need to consider first how many bits will make up 72. So the number of bits that will make up 72 is actually 7 bits. So to that, I'm going to have 2 raised by 0, 2 raised by 1, 2 raised by 2, 2 raised by 3, 2 raised by 4, 2 raised by 5, 2 raised by 6. And when I convert those values, they're going to give me 1, 2, 4, 8, 16, 32, 64 respectively. The next thing I need to consider is if I'm to convert 54 to binary form, what values am I going to consider here? Now 54 minus 64 will not be possible. Take note, I have to consider which value is higher. Is it the superhand or the minor end? So in this case, we have the superhand to be higher than the minor end. So I'm only going to consider the number of bits here. So this is why our bit is actually 7 bits. And it's spread between 2 raised by 0 down to 2 raised by 6. That will give us 7 bits. So back to what I was trying to do here, which is to convert 54 to binary. All I need to do is to consider what will sum up to give us 54. So this will not go, so it will be 0. 32 can go, so 54 minus 32 will give us 22. So we'll turn this on. Since we have 22, 16 can go, so 22 minus 16 will give us 6. So I'll turn this on. 8 can go because it's greater than 6. And then I'll consider 4 and 2 because 4 plus 2 will give us 6. And I was actually looking for 6. Then for the 1, we'll take that as 0. This is why our 54, with what I just solved, will give us 0, 1, 1, 0, 1, 1, 0. Now the same application would be done for 72. 72, what do we do? 64, 72 minus 64, yes, we can use that. That will be like 8. So we'll turn this on and we'll quickly look. Do we have value 8? Yes, we do here. So our 8 will be 1. So the other ones that doesn't apply will be 0. This is why my 72 is 1, 0, 0, 1, 0, 0, 0. So the next step to do is to start with the step 1, which is to take the 2 complements. So for you to take the 2 complements, you need to first of all check the first complement of 72. Now the rules of first complement states that whatever value you have in that bit, you take the opposite bit. For instance, if you have 1, you change to 0 and vice versa. So to that, at this point where we have 1, they will change to 0, 0. Whereas this point where we have 0, 0, 0, 0s, it will be 1, 1, 1, 1, 1. So this is why our first complement will be 0, 1, 1, 0, 1, 1, 1. Now, remember, we are asked to find the second complement, not the first complement. So how do we get the second complement? We'll just add 1 to the first complement, so which I have done here by adding 1 here. Now when you add 1, 1 plus 1 will be 0 carry 1. Now 1 plus 1 will be 0 carry 1. 1 plus 1 will be 0 carry 1. Take note, the carry is being indicated with the blue color 1 here. And we'll continue. 1 has no other thing to sum up, so it will be 1, 1 and 0. Now, how do you know if carry is generated or not? So we'll just look at that, but we have to consider the step 2. So at this part where we have gotten our second complement of 72 to be 0, 1, 1, 1, 0, 0, 0, we have to add the second complement to 54, which is the minor end, and this takes us to step 2. So for step 2, we are going to take the value, the binary form of 54, which is 0, 1, 1, 0, 1, 1, 0, and add it to the second complement of 72, which is 0, 1, 1, 1, 0, 0, 0. So we sum that, we're going to have 0 plus 0, 0, 1 plus 0, 1, 1 plus 0, 1, 0 plus 1, 1, 1 plus 1, 0 with a carry 1, 1 plus 1 plus 1, 1 with a carry 1. So we'll have 1 here. Now, the third step says if carry is not generated, result is said to be negative, and it is in its second form. So we are going to check, is there carry or not? So let's take a look at that. Now in this point, how many bits can you count? 7 bits, 7 bits, 7 bits. So there was no actually carry. How do you know if there will be a carry? Imagine if there's another digit here, it's going to be 8 bits, but in this case there will be no bits. So this is why it is 7 bits and no carry was actually done. So since carry is not generated, which we are now on the third step, step 3, since carry is not generated, then the result is said to be negative and in its second complement form. So we have minus 110, 1110. Now we move to step 2, where we are to take the second complement again for us to get the actual results. Now for us to do that, we are going to first of all check the first complement and then the second complement, just like we did previously. Now to that, like I said, whatever you have 0, you change to 1, and wherever you have 1, you change to 0 when we talk about first complement. So to that, this is changing as 1, this will be 0, this will be 1, this will be 0. So for our second complement is addition of 1, and when we want to add 1, we're going to have 0, 1, 0, 0, 1, 0, 0. Remember the negative, and then we have to convert this to binary because the question says 54 minus 72. Mathematically and logically, it is just minus 18. So we have to put this back in binary form, which is actually in base 18. So to that, we introduce the 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4, 2 raised to power 5, 2 raised to power 6, respectively, along each of these digits. So what is relevant? 1 here, 1 here. So what is it corresponding to? That's 2 raised to power 4, 2 raised to power 1. So we have 2 raised to power 4 plus 2 raised to power 1, which is 16 plus 2, which will give us 18. Remember the negative. So this is why the answer is minus 18. So just look at the side. Please, if you have not subscribed to this channel, please just hit the subscription. It's not expensive, it's cheap, free of charge. So just subscribe to this channel, like and share with your friends and family. So do well to watch my previous video. We have treated some examples on digital electronics and logic, and please look forward to seeing my subsequent videos. You can only do that by hitting notification bell so that you can get notified when I release a new video. Do have a nice time. Bye. Enjoy.